Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 9 students and the topic of discussion is triangles. So what is a triangle? It is a three-sided figure. It is a three-sided figure or a polygon where sides can be equal or unequal. The three sides and the three vertex corresponding here, and there are three angles associated with the triangle. So there are different types of triangles. For example, equilateral, it has all the three sides equal. Then isosceles triangle, where two sides are equal. Scalene triangle doesn't have any sides equal. All acute angles, which are less than 90 degree. Then this is a right angle triangle, where one of the angle is 90 degrees. And an obtuse angle triangle, where one of the angle is obtuse, meaning more than 90 degrees. These are different types of triangles. So what is congruence? Congruence means same shape and same size. For example, these two triangles we see, they are of same shape and same size. So they are congruent. These stars are also congruent. This pentagon is also congruent. These squares are also congruent. You may say this is slightly rotated. Yes, if we rotate it back clockwise, then this will exactly overlap each other. So these two figures are also congruent because they have same shape and same size. Similarly, these arrow marks, if I rotate this by 180 degrees, it will completely overlap here. So another condition of congruence is that same shape and same size, so they will overlap each other. So if I take this triangle over this, it will exactly overlap this. Let us check some other cases which are not congruent. For example, this is a bigger pentagon and this is a smaller pentagon. They have the same shape but the size is not same, so they are not congruent. This is very important. So what is CPCT rule? This you will be using throughout this chapter. They are corresponding parts of a congruent triangles. So it's called a CPCT rule. Let us try to understand what it is. Now consider two triangles ABC and DEF, where angle B is equal to angle E and angle A is equal to angle D. Let us rotate this and try to overlap this. Then we will see that D will exactly join A, E will join B and F will join C. So these two triangles are congruent. So how do we write? We write ABC is congruent to, this is the symbol of congruency. Triangle ABC is congruent to triangle DEF. The order of writing this is very important. So what does it mean? It means from this uh, rule, AB is equal to DE, BC is equal to EF and AC is also equal to DF. So this order of writing becomes very important. You cannot write triangle ABC is congruent to triangle EFD. It is not same. So if you write in proper order, the corresponding sides also will become equal. So again I repeat, AB will be equal to DE, BC will be equal to EF and AC equal to DF. So what is the criteria for congruence? There are different criteria. The first criteria is the SAS congruence criteria. What is SAS stand for? Side, angle, side. So when the two sides of a triangle are equal to the two sides of another triangle, so these two sides, AB is equal to PQ and BC is equal to QR, and the angles found by these two sides, the included angle. So what is angle included between these two sides? Is angle B and this is angle Q. So if two sides and the included angle of two triangles are equal, then the two triangles are congruent. Again we write triangle ABC is congruent to triangle PQR. So this is the condition we have to write. What is ASA criteria? ASA is angle side angle congruence criteria. If any two angles and the side included between the angles of the triangle are equivalent to the corresponding two angles, and the side included between the angles of the second triangle, then the two triangles are said to be congruent. So these two angles are equal. Angle C is equal to angle R and angle B is equal to angle Q, and side included between these two angles is BC. So BC is equal to QR. So it means that criteria angle, side, angle of the two corresponding triangles are equal. So triangle ABC is equal to triangle is congruent to triangle PQR. So again we can say that AB will be equal to PQ, AC will be equal to QR, and BC will be equal to QR. From this itself we can write. So what is the third criteria? Third criteria is side congruence criteria. If the three sides of a triangle are equal to three sides of another triangle, then the two triangles are said to be congruent. So here AC is equal to ZY, AB is equal to YX, and BC is equal to XZ. So we can write triangle ABC is congruent to triangle YXZ. And the fourth one is the RHS congruence rule. If in two triangles the hypotenuse and one side of the triangle are equal to the hypotenuse and one side of another triangle, then the two triangles are congruent. So this is a right angle triangle where angle B is equal to angle Y. The hypotenuses are equal, AC is equal to XZ, and one of the side is also equal. So BC is equal to YZ. Then these two triangles are congruent. So this is right angle, hypotenuse, and side congruence. So triangle ABC is congruent to triangle XYZ. Now this is a theorem. Angles opposite to the equal side of an isosceles triangle are also equal. So what is an isosceles triangle? It has two equal sides. AC equal to BC in this particular figure. So what we have to show, the angles opposite to these equal sides. So what is the angle opposite to side AC is angle B. Similarly, what is angle opposite to side BC is angle A. So we have to show angle A is equal to angle B. This is to be shown. Now let us divide an angle bisector for angle ACB. We will draw an angle bisector. It intersects AB at point D and CD will be perpendicular to AB. Now let us take these two triangles ACD and BCD. Let us try to see what happens in these two triangles. We will try to prove them to be similar. So AC is equal to BC, that is given because they are isosceles triangle, and CD is common to both the triangles, and this angle is equal to this, that is angle AC. D is equal to angle BCD. They are equal. From construction we have drawn that. So two sides and one angle are equal. So by SAS criteria, triangle ACD is similar to triangle is congruent to triangle BCD. So these two triangles are congruent. So angle A will be equal to angle B by CPCT criteria. That's what we need to prove. Now we will take another example. In this figure, OA is given to equal to OB and OD is equal to OC. We have to show that these two triangles are congruent. Angle AOD and BOC are congruent and AD is parallel to BC. This need to be shown. Now consider these two triangles, triangle AOD and triangle BOC. So this side is equal to this, AO equal to OB and OC equal to OD. These two are vertically opposite angles. So by SA SAS side, angle side criteria, these two triangles are congruent. That's what we written. They are congruent by SAS criteria. When they are congruent, these two triangles are congruent, the corresponding other angles are equal. So angle A will be equal to angle B by CPCT rule. Now, if AD and BC are two lines and BA is the transversal, and if angle A equal to angle B, the alternate angles, it implies that AD is parallel to BC. In this problem, E and F are respectively the midpoints of equal side AB and AC. So AB and AC are equal sides, and AE and AF are the also equal because E and F are the midpoints. We need to show that BF is equal to C. This we need to show. This can be done by proving that triangle ABF is similar to triangle ACE. This we need to show. So in triangle ABF and triangle AC, AB is equal to AC. This is given. They are the isosceles triangle. It is given here. Equal sides AB and AC. And angle A is common to both the triangles, ABF and ACE. And AF is equal to A. They are halves of equal sides. They are also equal. So hence these two triangles are similar. Triangle ABF is similar to triangle ACE. So if these two triangles are similar, they overlap each other. So it means ECCE will be equal to BF. That's what we need to prove. Let us take another example. P is a point equidistant from two lines L and M intersecting at point A. So these two are the lines L and M, and P is a point which is equidistant from these two lines L and M. Show that the lines AP bisect the angles between them. We need to show that AP is a line bisect, is an angle bisector. So what is angle bisector? If AP is an angle bisector, we need to show angle BAP is equal to angle CAP. This we need to show. So how do we proceed? We know that the shortest distance between a point and a line is the perpendicular distance. So and they are equal from two lines. So it has to be a perpendicular distance. So PB will be equal to PC. This is given, and these two corresponding PB is perpendicular to line L, and PC will also be perpendicular to line M. PB equal to PC is given because P is a equidistance point, and the shortest distance is the perpendicular distance, and since they are equal, they are the perpendicular distances. We need to show BAP is equal to CAP angle. These two angles should be equal. Now let us consider these two triangles PBA and PCA. We will consider these two and try to prove them to be congruent. So PB equal to PC in these two triangles, which is given. This is 90 degrees. Angle PCA equal to angle PBA equal to 90 degrees. It is given. PA is common to the two triangles. So these two triangles are congruent. Triangle PBA and triangle PAC, they are congruent. So triangle PAB is congruent to triangle PAC. So when they are congruent, they completely overlap each other. So angle CAP equal to angle BAP. So this is what we need to prove, and we have done so. Friends, with this we conclude this video. I hope you like my video. Please give a thumbs up to this video and like my channel and subscribe my channel so that in future all videos can be given to you instantaneously. Thank you very much, friends.